Let us discuss the Central Limit Theorem, CLT, Central Limit Theorem. I have a population of here. These are all the people. I don't know the size of the population. Too huge. Now what I am interested in the population is their heights. H1, H2, H3. Like that, it can be H million, H 10 million, whatever it is, right? So I want to identify population mean. Let us say height of average population, right? In India. In this case, this will become the Indian population. That's my problem statement, right? So I will choose the corresponding population. Okay. So what I will do is that I will take few samples here. Sample 1, sample 2, like that. I will take 1000 samples. Each sample, I will make sure that the sample size is minimum 30. Each sample should be containing n greater than or equal to 30 sample size. How many samples I have taken? 1000 samples. For all these 1000 samples, I will calculate the means separately. This is called the sample mean is called the point estimator. So the mean of the sample 1 is x1 bar. Mean of the sample 2 is x2 bar, like that. Mean of the sample 1000 is x1000 bar. What I would like to do is that I will plot this sample means into a distribution. What I get is that number 1, normal distribution. So this will be the normal distribution, a typical bell curve. Okay. For the normal distribution, mean equal to median equal to mode and left area equal to right area. This is half split at the mean median mode. This x bar, the means of all means, this is x bar equal to mu. When I say x bar equal to mu here, since these are all the, we have plotted this distribution using the sample means, the mean of 1000 sample means will be almost equivalent to the population mean. These are the two important things Central Limit Theorem says. One is irrespective of the original distribution, irrespective of the population distribution. When we construct a distribution with means of 1000, bigger number basically, the more the number is, the accuracy will be good. 1000 samples, each sample size greater than or equal to 30, then the distribution, those means will be normal distribution. So normal distribution mean equal to median equal to mode. If it falls in the normal distribution, typically the mean of that normal distribution will be equivalent to the mu, population mean. This is exactly what I want to achieve, right? There is an Indian population. I want to know the height of average height of those Indian population. Then I have taken the Indian population, but I don't have all the population of 140 crore data with me. So what I have done is that I have taken 1000 samples. I made sure that each sample contains at least 30 people. And then I have taken the means of all those 1000 samples and plotted the distribution. And I got the normal distribution. So when I got the normal, the mean of all those samples, the mean of all those means will be the population mean. So these two are important things to remember when it comes to the central limit theorem. If we look into some, maybe want to understand more, take one experiment, second experiment, 30, like that, 1000 experiments we'll do. First experiment, all these 30 dice, roll 30 dice, take the mean of it, call it as x1 bar. Second experiment, roll all those 30 dice, take mean of it, call it as x2 bar, like that. 1000th experiment, roll 30 dice, take mean of the outcome. So this x1 bar, x2 bar, x1000 bars are the mean of the outcomes. Let us say in the first roll, if we get 30 dice, right? 1, 2, 3, like that, some outcomes we'll be seeing, right? Take the mean of that particular outcome. Now, plot all these means, this will become the normal distribution. Okay. And another thing is that this mu, this average of these means will be equivalent to the, or will approach to the population mean. Almost approach to the population mean. That is the meaning of it. Thank you.